131 Principles of Microeconomics. In today's session, we will discuss Unit 8 and Unit 9. In Unit 8, iso-quant curve analysis, and in Unit 9 is returns to scale. So in today's session, we will discuss Block 3, Unit 8 and Unit 9. Iso-quant curve analysis and returns to scale with two variable inputs. In previous session, we have discussed about production function. Production function shows technical relationship between input and output. And we have studied about two laws of production function, that is law of variable proportion and other law is returns to scale. One law, which is returns to factor or law of variable proportion, is a short-term law. It's applicable in short run in which some factors remains constant, only one factor is variable factor. As well as we increase the units of variable factor, in the beginning production will increase. After that it will become maximum and at last it start falling. So law of variable proportion is applicable when we assume that in short time period some factors are constant and only one factor is variable, which is labor. And there should be no change in techniques of production and all the units of variable factors are homogeneous or same. And in long run, all the factors of productions are variable. All factors can easily change. If we take only one variable input, that indicates the law of variable proportion. But if we take that two variable inputs are given like labor and capital, or if all factors of productions are variable, then returns to scale law will be applicable in long run. Because all factors can be easily changed only in long run when we have too much time period, not in short run. Now, in today's session, we will discuss iso-quant curve. First of all, you must have to understand what is the meaning of this iso or quant. Iso means equal and quant represent quantity. So iso-quant shows equal quantity or same level of output. Iso-quant curve is a graphical presentation of different combinations of two factors of production, and if we use labor and capital, two inputs for the production of goods and services, and if these inputs will give us same level of output or same level of production at any combination. So this is known as iso-quant curve. Iso-quant curve is generally convex to the origin or downward sloping curve. Iso-quant curve is just the same as indifference curve, but the difference is that indifference curve represents consumer equilibrium and indifference curve is related with consumer theory, but iso-quant is related with producer theory and iso-quant is related with producer behavior, or it will show producer equilibrium. This is the just difference between indifference curve and iso-quant curve. Otherwise, same features, just like iso-quant curve has same features of IC curve, indifference curve. And indifference curve is also downward sloping curve, and it's always convex to the origin, same as isoquant curve is also downward sloping curve and convex to the origin. So in this chapter, isoquant curve, what is the meaning of this isoquant curve, what represent isoquant map, how we can get producer equilibrium or least cost combination or maximum output at minimum cost, how we can determine it, and what are the main features of isoquant curve, and what are the exceptional cases of isoquant curve. So all these topics we will discuss in today's session. Next is isoquant curve. What is the meaning of this isoquant curve? Isoquant curve is a line on a graph used in the study of microeconomics that charts all the combinations of inputs that will produce the same level of output. In other words, we can say that isoquant curve shows different combinations of two factors of production which will give us same level of output. So isoquant curve is a line or it's a graph which is always downward sloping, because as well as on x-axis we will always write labor. Labor is a variable factor and capital is a fixed factor, but in long run we can easily change all the factors of production. So if we increase the units of labor, then we will decrease the unit of capital. As well as we increase the unit of labor, we must have to sacrifice the unit of capital, because we know that resources are limited and wants are unlimited. So isoquant curve shows different combinations like A, B, C, D, different combinations of two factors of production like labor and capital, which gives the producer the same level of output or same level of production. That is known as isoquant curve. Now this is the table of or schedule of isoquant curve analysis. Here in first column, combinations we have taken. These are different combinations like A, B, C, D and E. And the units of labor in second column, you know that there are two types of technologies which can produce goods and services. One is labor intensive technology and other is capital intensive technology. In some countries, capital is abundant but labor is less. But in India, labor is more, capital is less. So each and every country, only one factor or one input is available in abundant quantity and other will be in less quantity. So if we use more units of labor, then we must use less unit of capital, because both are the techniques of production and both are not equally available in each and every country, so that as well as we increase the number of units of labor, we must have to sacrifice the units of capital. In this table, here first unit is of labor is 2. When we are using less unit of labor, then we will use more unit of capital. And here capital unit is 30. If we increase the units of labor from 2 to 4, then capital unit will fall from 30 to 22. Again, if we increase the units of labor 4 to 6, then the unit of capital will fall from 22 to 16. After that, again, if number of units of labor increases from 6 to 8 and 8 to 10, then units of capital will fall from 16 to 12 and 12 to 10. The ratio of falling in units of capital is 30 to 22. The gap in between of this is 8. And 22 to 16, here gap is 6. 16 to 12, the difference is 4. And 12 to 10, the difference is 2. It means we are increasing units of labor by same ratio, means 2, 4, 6, 8, 10. The gap is same, 2 to 2. But the sacrificing unit of capital difference is diminishing, because in the beginning the difference is 8, then 6, then 4, and last 2. So as well as we increase the units of labor, we must have to sacrifice the units of capital. But when the rate of the sacrificing and gaining the unit of labor is diminishing, in this case, isoquant curve will be convex to the origin, because if there is a diminishing marginal rate of technical substitution, law is applicable. In this case, isoquant curve must be convex to the origin or downward sloping. But if in any case this rate is increasing, then isoquant curve will be concave to the origin. And if this rate is same, it means we are increasing the unit of labor and decreasing the unit of capital by the same ratio. In this case, the isoquant curve slope will be straight line or negatively sloped, and it will not be a convex, not concave, it will be a straight line. So isoquant curve may be straight line curve, may be convex to the origin or concave to the origin. Its slope depends upon marginal rate of technical substitution. And what is MRTS? This marginal rate of technical substitution is the rate at which we have to sacrifice the unit of one input for gaining one more additional unit of other input. In other words, we can say that MRTS is equals to delta Y upon delta X or delta K upon delta L. Here K is capital and L is labor. Loss of capital divided by gain of labor. In first case, loss of capital is 8 and the gain of labor is 2. So the ratio will be 4 raised to 1. And in second case, 22 to 16, loss of capital is 6 and the gain of labor is 2. Ratio will be 3 raised to 1. And in next case, at D point or D combination, loss of capital is 4 and the gain of labor is 2. It means ratio will be 2 raised to 1. And in other case, ratio will be 1 raised to 1, because loss is 2 and gain is also 2. So ratio will be 1 raised to 1. So this rate is 4 raised to 1, 3 raised to 1, 2 raised to 1 and 1 raised to 1. So this is the diminishing rate. That's why isoquant curve slopes always downward from left to right and convex to the origin. If this rate is increasing, like 1 raised to 1, 2 raised to 1, 3 raised to 1, 4 raised to 1, then curve slope will be concave to the origin. And if the rate is same or constant, like 1 ratio 1, 1 ratio 1, in all different combinations, ratio will remain same. In that case, isoquant curve will be a straight line. And here isoquant is showing that if we are using two inputs like labor and capital, and different combinations are like A, B, C, and D and E, but we are getting here the output of clothes in same amount or in same level. Like 400, if we choose A combination, like 2 units of labor and 30 units of capital, we will get same level of output 400. If we take this B combination, then units of labor will be 4 and the units of capital will be 22, and we are getting same level of output 400. And in again C, D and E combination, if we use these combinations, different combinations of two factors of production, but we are getting same level of output 400. So this is called isoquant curve, which shows different combinations of two factors of production which gives same level of output to the producer. Now, what are the properties of isoquant curve? Isoquant curve has always negative slope. Its curve slope is always negative from and downward from left to right, and isoquant curve is always convex to the origin. Why this is always convex to the origin? Due to the applicability of law of diminishing marginal rate of technical substitution. As well as marginal rate of technical substitution is falling, this curve slope is always convex to the origin. Third property is non-intersection of isoquant curve. This property tells us that isoquant curve never intersect each other. If they intersect each other, it will give us inconsistent result, or mathematically it will be wrong. So isoquant curve never intersect each other. And fourth property is that in the isoquant curve may be more than one, and higher isoquant shows higher level of output and lower isoquant curve shows lower level of output. And fifth property is isoquant curve does not touch either to x-axis or y-axis. It means isoquant curve never touches to any axis. Either it may be x or y. It can never touches to any axis. These are the main properties of isoquant curve, which is just similar as indifference curve. Now, first property is convex to the origin. We have explained that isoquant curve is always convex to the origin due to the applicability of diminishing marginal rate of technical substitution. Higher isoquant represent large output. It means that we can draw many isoquant curve on a same graph like IQ1, IQ2, IQ3, IQ4. As well as isoquant curve moves to rightward, it will show higher level of output. And if it shifts to the left hand side or leftward, then it will show low level of output. So higher isoquant curve shows greater level of output and lower isoquant curve shows lower level of output. And in this diagram, the combination of different combinations of two factors of production, if we take, then we can draw different isoquant curve, and isoquant curve may be more than one, and higher shows higher output and lower shows lower level of output. Now next is two isoquant curve never intersect each other. You know that isoquant curve can never intersect each other because each isoquant curve represent different combinations of two factors of production which gives same level of output to the producer. If two isoquant curve intersect or touches to each other, this means that there will be a common point on the two curves as shown in the diagram. Here P is the common point where both isoquant curve are intersecting this point. It implies that the same factor combination we are using for the output. Labor and capital, which can produce say 100 unit of output at one isoquant curve, and on other isoquant curve 150 units produced by labor and capital, both inputs combination. So this is quite absurd because the same factor combination can't produce to different level of output. So and other thing, we know that higher isoquant curve shows higher level of output and lower isoquant curve shows lower level of output then how we can say that at the point of intersection, the level of output will remain same. The output will not remain same at the point of intersection. That's why isoquant curve can never intersect to each other. Next is higher ISO quant shows higher level of output. Here, IQ1 is showing that 100 units of output is produced by producer with a combination of two factors of production, and other IQ2 is showing 200 units of output with another different combinations of two factor of production. So higher isoquant shows higher level of output, and lower isoquant curve shows lower level of output. Now next is properties of isoquant. We can explain with the help of these curves also. Downward sloping, you know that isoquant curve is always downward sloping curve or negatively sloped curve. It's always convex to the origin due to MRTS. MRTS is marginal rate of technical substitution. Higher isoquant represent higher output and lower isoquant represent lower output. And no intersection by two isoquant curve. Isoquant curve never intersect to each other and never touches to any axis. So isoquant curve is always generally convex to the origin. Now, what are the various types of isoquant? Isoquant curve has three types. One is smooth convex isoquant. In first case, here isoquant curve is just smooth and convex shaped or downward sloping isoquant. So, isoquant curve generally smooth or convex shape curve, which represent different combinations of two factors of production which can produce by producer, and it will give us same level of output. Second case is linear isoquant. This is the second type of isoquant curve. Isoquant curve may be linear. When it will be a linear shaped curve? When perfect substitutability law is applicable, it means if both factors of production like labor and capital, if both can be easily substitutable, then in that case the rate of marginal rate of technical substitution will be constant or equals to 1. In that case, this curve slope will be downward and it will touch to x-axis and y-axis. It will be a straight line curve. So linear isoquant we can draw only in that case when factors of productions are perfectly substitutable. Otherwise, it will not be a straight line curve, because generally we know that isoquant curve is always convex to the origin. And in third case, third type of isoquant curve is input-output isoquant. If two factors of productions are complementary, or complementary means which always use together, we can't substitute it. In that case, zero substitutability exists between the factors of production. In this case, isoquant curve slope will be L-shaped curve or 90-degree angle. So in case of complementary, if factors of productions are complementary to each other, not substitutable or zero substitutability exists, in that case the nature of isoquant will not be convex, will not be straight line, it will be L-shaped curve or 90-degree angle. So these are different types of isoquant curves. Linear isoquant curve we can draw only in case of perfect substitutes, if production with only capital or only labor or through n numbers of combination between these two factors, then isoquant curve will be a straight line and it can touch either to x-axis or y-axis. Because if we are using whole amount of labor for the production of goods and services, then this line will touches to x-axis. And if we use all units of capital, here the units of labor is 0 because both factors can be easily substitutable. In that case, this curve will touch to the y-axis. And if we take different combinations of labor and capital input for producing output, in that case, if we join all the combinations, then we will get a straight line curve. So isoquant curve may be linear, but it will be applicable only in case of perfect substitutability, when factors of productions are perfectly substitutable. Next is kinked isoquant curve. Isoquant curve may be kinked if limited substitutability applicable between the factors of production. Kinked isoquant curve is also known as activity analysis programming isoquant or linear programming isoquant. If two cases are applicable on a same curve, then diagram will be kinked isoquant. Here, these are different lines like P1, P2, P3, P4. These are different production lines which are showing expansion path. And if we join all these points on P1, P2, P3, P4, then we will get kinked shape or isoquant curve may be kinked. Kinked means when the elasticity will not remain equal or same, not falling, not increasing, sometimes falling. If both cases are applicable on a same situation, in that case, diagram will be kinked shape. Next is smooth convex isoquant. Generally, isoquant curve is convex to the origin. It assumes that continuous substitutability of labor and capital only over a certain range, beyond which factor can't be substituted for each other. So this isoquant appears as a smooth curve convex to the origin. And generally, isoquant curve is always convex to the origin from left to right or downward sloping curve because factors of productions are not perfectly substitutable. As well as we increase the units of labor, we must have to sacrifice the units of capital. But if we are taking different combinations of these two factor inputs but getting same level of output, this is called isoquant curve. Now next is isoquant and isocost. What is the meaning of this isocost line and how this isoquant and isocost line both are important for determining producer equilibrium or least cost combination. The isoquant curve shows different factors which create the particular output, and the isocost line indicates the combination in factors which cost a similar amount. There are isoquant curve and isocost line indicating right combinations of the factors connected with production to create the highest output at least cost. So here, this straight line curve is known as isocost line. In other words, we can say that isocost line shows different combinations of two factors of production that can be affordable by the producer for production of goods and services. And isoquant curve shows different combinations of two factors input which gives same level of output and which is always convex to the origin. So this straight line is called isocost line And a convex shape curve is called isoquant curve, where isoquant curve and isocost line both slope are equal, and isoquant curve is tangent to the isocost line. That is uh, sh- that is called least cost combination or producer equilibrium. So isoquant is the locus of inputs that produce same level of output, and isocost line is producer's budget line. In indifference curve, we use budget line word or price line word, but in case of isoquant curve, we will show it by isocost line. Conditions of isocost line. Isocost line is always downward sloped or negatively sloped. The important condition which indicates the slope of isocost line, which is equivalent to the slope of isoquant. In equilibrium position, where the marginal physical productivities in two factors show equal to the ratio in the prices, marginal physical product for every rupee of a particular factor has been equal to the other factor. So, where the marginal productivity of capital divided by marginal productivity of labor, if this ratio is if the ratio in between of capital and labor both are negative, so that in case slope of isocost line will also negatively sloped. Isocost line shows a negative relationship between labor and capital. If producers spend entire money income on capital units, then labor unit will be zero. And if producers spend entire money income on buying the units of labor, then capital unit will be zero. And if he spend his money income on two factors of production for the production of goods and services, in these case, we will take different combinations. And if we join all these combinations, then we will get isocost line. So isocost line is just a same as budget line in case of indifference curve, but isocost line shows producer's budget line, on which producer spend his income on two factors of production like labor and capital, where the slope of isocost and slope of isoquant both are equal, then producer equilibrium will be determined. Here, this is the graph of isocost line. Isocost line is always downward sloping curve or negatively sloped curve, and its formula is MPK upon MPL. MP is marginal productivity of capital upon marginal productivity of labor. Or we can write in this form like PK upon PL, price of capital upon price of labor. And its slope is always negative. Next is isocost and isoquant curve. If we combined draw both isoquant and isocost curve on a same curve, then this straight line is showing isocost line, and the convex shape curve is showing isoquant curve, where isoquant curve is tangent to this isocost line, then producer equilibrium or least cost combination or maximum output at minimum cost we can determine. Here, three isocost lines are drawn. One is in between of this. This line is actual isocost line, and isocost line may be shift either to the right hand side or left hand side. If budget of the producer increases, then producer can afford both the factors in same amount. In this case, this isocost line will shift to the right hand side. And if budget of the producer decreases, then producer can afford both the factors in less quantity. In this case, isocost line will shift to the left hand side, so that we can get three isocost line when producer's budget income increases or decreases. And where isoquant curve is tangent to these three isocost line, producer will be at equilibrium point. Here three equilibrium points we get. This is known as producer equilibrium points, and this curve is IQ1, IQ2, IQ3. So producer always determine or reach at the equilibrium point where the slope of isocost line and the slope of isoquant curve both are equal. So if there is an imperfect substitution between labor and capital, in that case, isoquant curve will be a convex to the origin, not concave, not straight line. And K and L, K is capital, L is labor. Choice depends on wage and the reward of labor is wages and the reward for using capital is rent. So W by R ratio, marginal rate of technical substitution, we can calculate by MPL upon MPK. Here MPL is marginal productivity of labor divided by marginal productivity of capital. And here this red line shows isoquant curve and the straight line negatively sloped green line is showing isocost line, and where both curve are tangent to each other, here we can get producer equilibrium. So producer is always determined at equilibrium point, and we can determine equilibrium point at that point where isocost line is tangent to the isoquant curve. Here is the point of cost minimization. How producer can decrease the cost and increase the output level. Assuming that the firm takes as given the prices of two inputs it employs, it will seek to produce its output by utilizing its input in their most efficient combinations. A rational firm seeks to employ a unique combination of capital and labor that is capable of producing a predetermined level of output at the least possible cost. The cost minimization input combination like labor and capital at the point of tangency between the isoquant curve and the isocost line. Here, three isocost lines are drawn. One is this TC1 upon PX, this PX or PK upon PL, and another line. This is the actual isocost line, and rightward shift isocost line is representing that producers' budget income increased due to increased in budget income. Producer can buy both the inputs in more quantity. And if producer's income fall, then this isocost line will shift to the left hand side. But in actual isocost line, where this isoquant curve, which is always convex to the origin, at E point, where isoquant curve is tangent to the isocost line, this E point is showing cost minimization or maximum level of output with the help of two factors input, where the slope of isoquant is equals to slope of isocost line, that is called producer equilibrium. This is the first condition of producer equilibrium. We can find out the slope of isoquant with the help of MRTS, and the slope of isocost line we can determine with the help of price of labor upon price of capital. Marginal rate of technical substitution is equals to marginal productivity of labor upon marginal productivity of capital, and slope of isocost is equals to PL upon PK. So where MPL upon PL is equals to MPK upon PK, this is the necessary condition for cost minimization. MPL is marginal productivity of labor is divided by price of labor is equals to marginal productivity of capital is divided by price of capital. This is the necessary condition of cost minimization, or getting maximum level of output. At B point, here E point is the equilibrium point, but B point is not the equilibrium point because here isoquant curve is cutting to this isocost line. So this B point will not be called cost minimization, and C point will also not be called cost minimization point. Only E point is equilibrium point where producer is getting maximum output at minimum cost. So least cost combination you can determine with the help of this diagram. We have discussed earlier that where isoquant curve is tangent to this isocost line, here this point is showing point of cost minimization, and this line is isoquant curve and the straight line curve is isocost line, where the slope of isocost is equals to slope of isoquant, that is showing least cost combination or producer equilibrium. Now next is ridge lines. What is the meaning of ridge lines and why these ridge lines are important while we are discussing about production function and isoquant curve? How ridge lines represent the economic region of production. Not all points on an isoquant are relevant for production. One should consider only feasible portions of an isoquant because no rational producer will produce where the marginal product of an input is either zero or negative, because a rational producer always want to produce maximum output at minimum cost. So rational producer will not choose that combination where marginal productivity of any input is either zero or negative. Only the negatively sloped segment of the isoquant is relevant for production or economically feasible. Now in diagram, first of all here marginal rate of technical substitution, ridge lines shows profit maximizing condition, or ridge line shows economic region where producer can get maximum profit. Ridge lines shows that profit maximizing firm operate within because outside of them marginal product of input are negative. So economic region of production is located within the ridge lines. These are two ridge lines. Start from the origin. One ridge line is known as upper ridge line. At this upper ridge line, marginal productivity of capital is zero. And second ridge lines, we start from the origin, but this is the slope of upward sloping. This shows lower ridge lines. This lower ridge line indicating that marginal productivity of labor is equals to zero. And these three are isoquant curve like Q, this is IQ1, IQ2, IQ3. And you know that the ridge line shows economic region or profit maximization condition. Here point A, here point A on first isoquant curve A and D. A firm is producing in between of this range. That will be called economic region, or most efficiently firm can produce by using two inputs, and B and another this point, B and E point, if we take this, then this is also called economic region point, and C point is also economic region point. So upper ridge line shows marginal productivity of capital is zero, and lower ridge line shows marginal productivity of labor is zero. But you know that a rational producer will not choose that production level where marginal productivity of labor is zero or negative, or marginal productivity of capital is zero or negative. So in between of this economic region, where isoquant curve lies in between of these ridge lines, that will be called efficient or maximum output level. So generally ridge lines represent the economic region or economically how a rational producer can get maximum level of output. Now next is expansion path. Expansion path shows locus of different factors of production like inputs, labor and capital in long run and in short run. How we can get different levels of input by using these maximum level of output. In long run, you know that all factors of productions are variable. So in long run, we can increase both the inputs, labor and capital in same proportion. So expansion path will be a 45-degree line. But in short run, we know that fixed factor remains always fixed. Only variable factor units can change in short run. So in short run, expansion path will be horizontal line because capital we have taken on y-axis, and in short period capital will remain constant. Only labor unit can increase. So in short run, expansion path will be a horizontal line, and long run expansion path will be a 45-degree line. So expansion path we can draw in a long run and in a short run. In a long run, this expansion path line will be a 45-degree line, and short run expansion path line will be a horizontal line which is parallel to the x-axis. Now next is expansion path. Why we use this expansion path? Expansion path can be used for differentiating between returns to scale and returns to factor, because both the laws are applicable in different situations. Like returns to scale is applicable in long run and returns to factor is applicable in short run. So here this OP line which is a 45-degree line, it's a 45-degree line is a expansion path, and these are three iso cost lines, and where isoquant curve is tangent to these iso cost line, that is the producer equilibrium point. Here 3 points like L, M, N, these 3 points are equilibrium points, and we can get expansion path in this way also. If we take a 3 isocost line, then 3 isoquant curve which is tangent to these 3 isocost line, then we can get 3 equilibrium points, and if we join all these points, then we can draw or derive expansion path. So expansion path, this is the curve of derivation of expansion path. And how we can draw price factor curve? Price factor curve is just same as price consumption curve. In that case, we assume that the price of capital remains constant, only the price of labor varies. If price of labor falls, we will use more labor. If price of this line will rotate outward, and if price of labor increases, then producer will use less labor. In that case, this curve will rotate leftward, and where isoquant curve is tangent to these three isocost line, then we will get LMN, three equilibrium points, and if we join these 3 equilibrium points, then we will get a curve which is known as price factor curve. Now next is, you know that returns to scale is applicable in long run, and in long run all the factors of productions are variable. Returns to scale has three stages. One is increasing return, second is constant return, third is diminishing returns to scale. Increasing returns to scale will be applicable when inputs we use less and get same level of output. For example, here the units of labor we are using, like first is expansion path. OR is expansion path line which indicating long run expansion path which indicating returns to scale situation. And here three curves are isoquant curve. Like one isoquant curve is representing 100 level of output, second isoquant curve is representing 200 level of output, and next is showing 300 level of output. But the gap in between of these three curves, like point A and point B and point C, you know that here it is clear the gap in the beginning is more and after that is less. It means AB is greater than BC. So it means as well as we're decreasing the units of input but getting same level of output, or in other words, if we use less amount of input but get more amount of output, that will be the stage of increasing returns to scale. Next is constant returns to scale. Constant returns to scale, this stage is applicable when the ratio of input and the ratio of output both are equal. If the ratio of input and ratio of output both are same, like L1, L2, L3, the ratio of this and the capital ratio is also K1, K2, K3, and the gap in between of all these isoquant curve, like one isoquant curve which is showing 10 level of output, second isoquant is showing 20 level of output, and next isoquant is showing 30 level of output. The difference is same, 10, 10, 10. And the gap in between of this A to B point and B to C, the gap in between of this is also same. So this is the stage of constant returns to scale, where OA is equals to OB is AB is equals to BC. If the unit of inputs and the unit of outputs both are equal, that is the stage of constant returns to scale. In other words, if we use 10% input and get same 10% output, it will be show constant returns to scale situation. Constant returns to scale is also known as homogeneous production function. Homogeneous production function is the stage of presented by Cobb-Douglas. Cobb-Douglas always says that there is a homogeneous production function situation when we use same level of input and get same level of output, then it will show same amount of input and output, ratio is same. In that case, homogeneous production function law will be applicable. Here three lines are isocost line, like first is AB, next is A1B1, next is A2B2. These three straight lines are showing isocost line, and three isoquant curves IQ1, IQ2, IQ3, which is always convex to the origin, where these three isoquant curve is touching to these three isocost line, equilibrium point will be determined like E1, E2 and E3. If we join these three equilibrium points, then we will get expansion path, which is the long run expansion path, and it will be showing the same amount of input and same amount of output. So this is known as homogeneous production function. Now next is diminishing returns to scale. Diminishing returns to scale stage will be applicable if we use more units of input but get less amount of output. So here first isoquant is showing 100 unit of output, second isoquant is showing 200 unit of output, and next isoquant is which is convex is showing 300 unit of output. And this OP line is expansion path, where this line is touching to this expansion path, where this isoquant curve is touching to this iso expansion path line, we will get three equilibrium points like A, B, and C. Now here it is clear that the gap in between of OA is less than AB, AB is less than BC. It means the gap in between of these isoquant curve is increasing but getting we are same level of output. It means we are using more amount of input but getting same level of output or same amount of output it will show diminishing returns to scale situation. So in diminishing return, OA will be less than AB and AB will be less than BC. But in case of increasing return, OA will be greater than AB and AB will be greater than BC. And in case of constant return, all will be equal. OA will be equals to AB, AB will be equal to BC. So these are the three situations of returns to scale which we can represent it with the help of isoquant curve and expansion path line. Now next is returns to factor. You know that returns to factor is a short-term law, which is also known as a law of variable proportion and a law of diminishing return. Returns to factor is applicable in short run when some factors are constant, only one factor is variable factor. And if we use all the variable factors or if we increase the amount of variable factor one by one with fixed factors units, in that case, in the beginning, production will increase. After that, it will become maximum and at last it start falling. So, you know that in short run expansion path, it will be a horizontal line. So here RP line is a horizontal line which is parallel to the x-axis, which is indicating that we are taking short run situation, and in short run we can't increase fixed factor unit like capital. We can change only variable factor input like labor. So here we have drawn four isoquant curve like IQ1, IQ2, IQ3, IQ4, and all these curves are showing amount of output like 100, 200, 300, 400. The amount of output increasing by same level like 100, 100, 100. The gap in between of all is same. But main thing is that here EF, the gap in between of these four isoquant curve, first isoquant curve where it touches to this expansion path line, we will get equilibrium point, E point, on another curve, F point, another G point, and next is H point. If EF is greater than FG, FG is greater than GH. It means showing it. This is showing that we are using less amount of input but getting same amount of output. If we are using less amount of input but getting same amount of output, it will show increasing returns to factor stage. In second case, the gap in between of these E, F, F, G, G, H, if all are equal, if EF is equals to FG is equals to GH, if we are using same amount of input for getting same amount of output, this will show constant returns to factor situation. And third is diminishing returns to factor stage. Diminishing returns to factor will be applicable when the gap in between is EF is less than FG and FG is less than GH. It means the gap is increasing. It means we are using more amount of input for getting same amount of output. So this stage is showing diminishing returns to factor stage. So we can also represent law of variable proportion with the help of isoquant curve analysis. Now next is what is the difference between returns to a variable factor and returns to scale. Returns to variable factor, as you know that it is applicable in short run, and returns to scale law is applicable in long run. In short run, all the factors of production we can't easily change. Only one factor is variable factor, we assume that, and others are fixed. And in case of returns to scale, all factor inputs are varied in the same factors of production. In case of returns to a variable factor, there is a change in factor proportion. Suppose 1 acre of land and 1 labor is employed, the ratio will be 1:1. And if we add one more unit of labor on the same land area, 1 acre land, then the ratio will be 1:2. but there is no change. In case of returns to scale, there is no change in factor ratio. For instance, if a firm is employing 1 unit of labor and 2 units of capital, then the ratio will be 1:2. Now, if the firm increases its scale of operation and employ 2 units of labor and 4 units of capital, the ratio will still remains the same as 1:2. So in case of returns to variable proportion, will be no change in scale of production, but in case of returns to scale, there will be a change in scale of production. Now we can conclude from today's session that we have discussed about isoquant curve, which is known as equal product curve. Same as indifference curve, isoquant curve never touches to any axis, never intersect each other. Every possible combination of input is on isoquant. And isoquant map is indicating the family of isoquant curve. Now we have completed this isoquant curve and production function. Thank you.